Let's now take a look at using Surface High-Speed Toolpaths for rest milling operations. Here I have this part roughed out using a Surface High-Speed core roughing operation with a 3/4 inch bullnose end mill. Let's go ahead and verify that and take a look at what we've got. There's our completed roughed part. The steeper areas look pretty good. This outer area and these steeper tapered bosses. However, these shallower tapered bosses have some pretty pronounced stair stepping on them, and also this center area between these bosses that 3/4 inch tool could not fit into, so there's a whole section here that's unmachined. I'm also going to save this as an STL file so we can verify from it for future operations. I'm going to save it as core rough and exit out. Now to create the rest milling operation, I'm just going to right click, drag, copy after, collapse my roughing operation, and go in and start to change some parameters here. Now I leave the toolpath type the exact same of what I had before, drive surfaces and containment boundary. However, my tool, I'm going to switch that to a 1/2 inch bullnose end mill. I go into my cut parameters, and my step down for the previous operation was 75 thousandths of an inch. The default for a 1/2 inch tool here, Mastercam's telling me 50 thousandths might be a good value. However, I'm going to make that 25 thou, a little bit finer finish. To create a rest milling operation, all I have to do is turn on this rest passes feature and also enter my roughing tool diameter, which was 3/4 of an inch, and the corner radius, which was 30 thou. Let's go ahead now and regenerate. Now, rest milling passes take a little longer to regenerate because it has to refer to the previous operation and calculate how much material to remove. So I'm going to pause the video here for a moment while this regenerates, then resume after it's finished. Okay, let's now backplot that. Take a look at what we've got here. Okay, that looks pretty good. However, it's machining passes on this outer area, which I certainly don't want or need. And also, it's doing a little bit too much work on this fillet here, this large outer fillet. Now, there's a couple different ways we can limit the motion. I could either set a containment boundary and have it keep inside that boundary, or I can limit it to certain Z depths. I'm going to go into my parameters here, steep, shallow, turn on use Z depths, and I'm going to type in the question mark. I'm prompted to select the coordinate of a point for my minimum depth. Now this is going to be the uppermost cut level. I go back to my screen. I'm going to select the top of this boss here, and the value is filled in there. For the maximum depth, I'm going to enter Z, enter. Again, I return to my screen to select a Z level. I'm going to select the floor of this. Okay, and now let's regenerate again and see what we've got. Okay, let's backplot that now. That looks pretty good. However, it still just takes one pass around the perimeter. Let's leave that for now. Go into verify and see what things look like. I'm going to select that STL file I created as my stock. Okay, that looks pretty good. I'm going to zoom in a bit here. And we can see that those bosses got machined, and this area in here certainly got cleared out. I'd now like to try and eliminate that final pass around the perimeter. We'll exit out, go back, and change my Z depths a little bit more. Now my stock to leave was 10 thousandths of an inch, which we can see if we go into the cut parameters, stock to leave 10 thousandths of an inch. And when I selected my maximum depth, I selected the floor of the model. The actual stock left is 10 thou more than that. We'll regenerate that. Back plot. That looks like a little bit better of an operation now. We'll do a verify one final time here. You can see I got some better clean out in the center here, and I eliminated that outer pass. Exit out, and a few other things to know about rest milling with surface high-speed toolpaths. This is not tied to this previous operation like in traditional Mastercam surface rest milling. It's its own toolpath, so if we change any parameters in the first operation, it won't affect anything in this rest milling operation. In other words, these two are not linked together in any way. The only thing that denotes that this is a rest milling operation is this toggle here, the rest passes. Here's where we left our part with our core roughing toolpath. Let's now work on some rest milling ops to get this closer to size for some finishing. Now there's several ways to work with rest milling operations, one of which involves a CAD file. And that CAD file is going to be in the form of an STL. What we have to do, however, is save our roughed model here in Verify as an STL file. So I'm in Verify, this is completed, and then I go to Save Stock as File. Now it's important to keep in mind where this file is saved and don't lose it. I usually just let it go into the default location. Save, then exit. Okay, now we're ready to do some rest roughing. What I'm going to do is copy this operation here, right click, hold the button down, drag it after, copy after. We'll go into the parameters, toolpath type, switch it out to a rest roughing, and we have all of our surfaces and faces maintained since we copied it. Now for a tool, let's try this 5/16 bullnose end mill, and then cut parameters. We want to climb cut, and then very important here, this little button use core mill passes. What this will do is cut with our core mill style toolpath, cutting from the outside in. We got a 30-second step down. Let's bump that up a little bit to 50 thou maybe. Have our add cuts on. Minimum step down, we turn this up a bit, 10 thousandths of an inch, and turn down the maximum profile a bit. My stock to leave, I'm still going to have 20 thou there. And then go right into my arc filter, double check that this is half of what my stock to leave is, which it is, 10 thousandths. And then rest material. Okay, this is where all the action happens with the rest milling operation. We have 4 different ways of how this op can interrogate our file and see what material is left. We have all previous operations, one other operation, a roughing tool, or a CAD file. So we just saved that verify as an STL file. So I'm going to select CAD file here for this first example. Click OK. And then when I hit regenerate, it will tell me operation does not have an STL. So I need to go out into my geometry, select CAD file here, and then go and pick up my CAD file that I saved, that STL. And it's giving me a little preview of what material is left. We can see this big fillet down here. It's superimposing that STL on top of my original part. And now I can regenerate. And then we'll backplot. And see that tool just nicely going after my outstanding boss. Once again, with very good arc motion and a smooth tool path. And we'll go into a verify, and we'll start from where our roughing left off. And there's a good rest milled part, ready for some finishing ops.